In nature, males will do anything to mate with a female. They'll offer gifts, engage in elaborate dances, but most frequently, they'll beat the hell out of each other. But the combat doesn't stop there. The winner of the fight on the outside must still face another, much more brutal battle on the inside, where microscopic wars lead to millions of casualties, and where physical and chemical weaponry is developed in a high-speed militaristic arms race, all inside the female reproductive tract. Today we're covering sperm competition in nature, every surreal sperm adaptation it's caused across animals, and the surprising effects it's had on human evolution. So come with me as we explore this, but don't come against me, because my sperm will beat the hell out of your sperm. Sperm competition is the result of exactly that. Competition. I mean, these elephant seals aren't exactly having a friendly contest, are they? The two bulls ram their bodies into each other like a giant thumb war, and viciously bite each other's noses and necks, drawing blood until only one is left standing. Or flopping, I guess. See, the winner gets sole control over a harem of 20 to 50 females, able to mate with any and all of them so freely and carelessly that they sometimes accidentally crush the females and even their own babies to death, while the loser has to hang his derpy nose in shame and flop away with zero reproductive potential on the table. The official term for the dominant elephant seal is beachmaster, which is very fun, so shout out to whoever came up with that. However, none of this is fun for the beach losers, who aren't strong enough to ever think about challenging the current heavyweight champion and can only hover around and watch. But they haven't given up entirely. See, hovering elephant seals are frequently seen trying to mate with females near the edge of the harem and then flee as quickly as possible. And while this effort is typically thwarted by the beachmaster quite easily, getting to reproduce is worth so much that non-dominant males will spend their entire breeding season lying around, subjecting themselves to this cruel cuckoldry, all for the slight chance that they may be able to sneak in and steal a mating. That's how steep male-male competition is. Thus, sneak mating in this way is a very common strategy in nature. Watch as this brown trout flies in, quickly ejaculates all over a female's eggs, then swims away. Also, notice how this male is so much smaller than this one? These are two males from a couple different species. As you can see, there are two distinct forms within each. There are the large garter males, which win over females through brawn the old-fashioned way, and small sneaker males, which use their small size to quickly steal matings from larger fish. Not every male can be the biggest and strongest, and so lineages of non-dominant males separately evolve an alternative peak male physique that emphasizes stealth and speed over size and strength to still fight for a chance their own way. Sneak mating is interesting because it circumvents the traditional view of male-male competition, where one male is the gigachad who wins the female and gets to pass on his genes, while the other is the loser that dies forever alone. Instead, a dominant male can mate with the female, and then another male can sneak in and inject sperm into her anyways. Imagine doing all that work to win over your dream girl, and things are going well and you're trying for a kid. Then a Smurf runs up and somehow bangs her and disappears. And now, when she says she's pregnant, you can't be sure that the baby isn't gonna pop out a little blue. Losing your guaranteed paternity in this way would suck. And so there arises a new competition: sneak mating versus mate guarding. It's a behavior seen in nearly all mammals, birds, insects, and fish, where males physically guard a female to deny rivals an opportunity with her. Most animals do this by just chasing other males away, but this can be taken much further. In red-veined darters, the male dragonfly will clasp onto the back of the female's neck with his tail after mating with her, staying firmly attached to her and flying together as a pair, only releasing after she lays her eggs. Many animals find ways to physically plug the female reproductive organ. Kangaroo semen coagulates shortly after ejaculation, sealing the female tract like superglue, preventing future males from properly mating with her. In giant wood spiders, males sever their own genitals, breaking it off to create a plug, though in this species, females can also make their own plugs to prevent unwanted sex. Red-sided garter snakes deposit a gelatinous plug, sealing the female cloaca, but this gel is also filled with chemicals that that alter her pheromonal signals, which makes her less attractive to other males. But alas, mate guarding doesn't always work. You can't be 100% vigilant all the time, especially when life demands other things of you, like finding food or running away from predators. So sneaker males will inevitably find their way through. Additionally, females of many species don't always want to be guarded, and may seek out other males and remove mating plugs on their own. This may be after a female notices a different male of a higher quality after already mating with one, or sometimes females take new partners to protect themselves from sexual aggression on the part of their current partner. And so, oftentimes we have scenarios where multiple males have injected sperm into a single female. And when this happens, what decides whose sperm gets to fertilize the egg? Well, seems pretty obvious, right? The fastest sperm should reach the egg first, and so males that adapt to have faster sperm should be more successful. The midpiece of human sperm is filled with mitochondria, the, say it with me now, powerhouse of the sperm. Yeah, which gives it a lot of energy to whirl its flagellum at a Michael Phelps pace, moving at a speed developed over generations of sperm competition. But speed isn't everything. If you produce more sperm, you have more Olympians in the race. A single human ejaculation contains anywhere between 40 to 300 million individual sperm. It's simple. The more sperm you provide, the better your odds for one of them winning. Male dunnocks who recognize a female has already been mated with will peck at her cloaca, dislodging the semen of the previous male to ensure that he has more sperm in the race than the previous male. But the sperm of the fruit fly, Drosophila bifurca, goes to much further lengths than this. Literally, like their sperm is really long. At 5.8 centimeters or 2.3 inches, it's the longest sperm of any living organism. For the record, D. bifurca's average body length is about 3 millimeters, meaning their sperm are about 20 times longer than their own body, just coiled up extremely tightly. It's thought that the reason for this length is that the female sperm receptacle in fruit flies is pretty long, and there's a competitive advantage to males with longer sperm. There are several other weird sperm types that show up in nature. But before we get into them, what makes sperm competitions so cool is the vast diversity in which animals display it, no matter how microscopic it is. But zooming out, this wonderful diversity has been declining as the environment continues to be destroyed. Let's not give up hope though. I believe that together we can change this, which is why I'm partnering with my friends at Planet Wild. Planet Wild is a 13,000 member community-funded organization that helps rewild forests, protect endangered species, and clean up our oceans all across the world. Think of it as crowdfunding for nature. Every month they fund a new conservation project with their carefully selected partners. Their latest project really inspired me. They're protecting the Amazon rainforest, the most biodiverse place on Earth, and also one of the largest carbon sinks on the planet. Crucial for preventing extreme climate disasters globally. Planet Wild is helping indigenous tribes preserve their land by funding forest patrols, providing equipment for stopping the spread of fires, and attempting to get the region legally recognized as a UNESCO Biosphere Reserve and World Heritage Site. It's just one of several amazing initiatives that you can support and be a part of through Planet Wild's community. I myself am a member of Planet Wild. I have always loved the natural world. It's why I make these videos and why I'm pursuing my PhD in biology. But I've always been anxious about making sure my money goes directly to the right causes. On Planet Wild's YouTube channel, you'll get a fun, educational, 100% transparent video every month showing what your contributions help to achieve, the impact each project has, and the long-term outcome. As a YouTuber, I'm actually very impressed by the quality of these videos. I really encourage you to check them out in the link below. You can also get updates on their app, interact with the Planet Wild community, and receive unique mission badges for your support. So if you want to make a difference, scan the QR code on screen or click the link in the description so you can be a part of the solution. The first 150 people to sign up using my code DAN8 will get their first month on me, because I want you to see for yourself that Planet Wild is an organization worth supporting. You can sign up for a flexibly priced membership based on what you can afford. Every dollar counts. The best part? You'll see your impact in less than 30 days. And if you don't feel like supporting Planet Wild anymore, don't worry, you can cancel anytime. Join a community of people who care about nature and want to protect it, not with empty words, but with real, measurable measurable action. Let's make a difference together. Back to the video. Passerine bird sperm are twisted in a helical shape, like a drill, that improves motility. Motility isn't the same as mobility. Here it refers to the ability to move within a specific substance rather than a general medium. For example, some sperm may be able to move faster in water, but not so fast through the often viscous fluid of the female reproductive tract in certain species. Quacking frogs also have twisted sperm, and they show the advantage of this quite nicely. The more twisted sperm that moves at slower velocities are found to exhibit more fertilization success than faster sperm that's less twisted. Actually, in a 2009 experiment, slower twisted sperm even outcompeted faster twisted sperm for some reason. So it seems there are many factors besides speed that determine the winner of the sperm race, many of which are unclear. Partially it's because it's hard to observe sperm in the first place, but it's especially tricky when every single organism has completely different sperm competition dynamics, which leads to different shapes and behavior in their sperm. However, what is clear is the importance of sperm competition on male behaviors. Not only are mate guarding, mating plugs, and the cleaning out of the genitals all direct consequences of trying to minimize it, many animals adjust the amount of semen they produce based on the amount of sperm competition they perceive. This is called ejaculate economics, or prudent sperm allocation. In Norway rats, males that mated in a cage with only a female produced significantly less sperm than males that mated in a cage with a female and another male present behind a plastic screen. Sneaker males in fish and squid are found to have better sperm swimming speed, persistence, and lifespan when compared to dominant males in the same species. Given that the entire sneaker male strategy hinges on engaging in sperm competition rather than traditional competition, it makes sense they would invest more resources into higher quality sperm. There's even some research that measured ejaculate size in humans and found that males that reported to spend more time away from their partner and thought that she may be exposed to other men produced more sperm than males that spent less time away from their partner and felt less about the presence of other men in her life. Now, this research is a bit contentious. There could be a lot of other factors when it comes to human sex, but whether or not this is true in humans, prudent sperm allocation is a phenomenon that's clearly observed across the animal kingdom. But male behavior is only one part of the equation. It turns out females have a lot of control over what happens inside them as well. In separate studies, researchers mated guppies and crickets with random mates and with mates that were genetically related to them. It's well known that inbreeding tends to lead to, let's say, non-favorable evolutionary outcomes. And so it would be in a female's best interest to use a stranger's sperm rather than a sibling's. And that's exactly what they found. In both experiments, females biased their offspring to be more often descended from non-related mates, rather than their relatives, even when mated with both to the same degree, suggesting an internal mechanism in females to avoid inbreeding by favoring sperm that's less genetically related to them. It's thought that there are proteins present in the reproductive tract and on the surface of the egg that are responsible for this. Human eggs release chemoattractant signals that are only picked up by about 30% of sperm, and these chosen sperm show greater genetic compatibility with the egg. This is an example of cryptic female choice, where a female influences which and whose sperm gets to fertilize her eggs. As I said earlier, females in many species prefer to take multiple mates, and this is something that Darwin never understood. In his original theory of sexual selection, he postulated that females should want one mate with a focus on quality, while males should be the one that want to spread their seed as far as possible. The theory makes a lot of sense, except it could never explain the widespread existence of polyandry, when females take multiple partners. But cryptic female choice can account for this. There's no worry of low quality offspring when, at the end of the day, you can simply select the highest quality sperm internally. In sand lizards, the more males that a female mates with, the lower their rates of hatching failures and the better their rates of offspring survival. In some birds, like chickens, gulls, and dunnocks, females are known to straight up eject the sperm of males they don't like. Beetles and flies can commit spermicide, releasing a chemical weapon that degrades sperm within themselves, which they do more often after mating with low-quality males. In geladas and some species of rodent, females can even terminate their pregnancy after fertilization. Just as male-male competition isn't over after sex, neither is female choice. So, sperm aren't only in a race against the sperm of other males, but also in conflict with the female, who may consider them low quality. Much like in actual war, soldiers don't only face their adversaries, but the very environment in which they fight. But, much like in actual war, teamwork makes possible what one man could only dream of alone. The sperm of wood mice have this strange hook on their head. One quick look under a microscope reveals its function. It allows the sperm to connect together from hook to hook and hook to tail like a bunch of interlocking safety clips. These groups can consist of 2 to thousands of individual sperm, forming a massive sperm train that charges forward in unison. The shared momentum and shape of the train allow the sperm to push through the wood mouse reproductive tract, like a giant battering ram, allowing them to be 50% more motile than a sperm swimming solo. This is an example of sperm cooperation, an altruistic behavior where several sperm band together, potentially sacrificing their own chance for success for the sake of a few to prosper. And they can do this because they're genetically related. What's important in evolution is that your genetic material gets passed down. So, sperm of the same male don't have to be selfish and compete with each other. Instead, they can put their forces together, like a massive spirit bomb, sending one to live a life for the millions left behind. In diving beetles, sperm cooperation is seen in a number of forms. They sometimes pair together side by side, or they form a chain structure called a rouleau, where the head of one sperm is nestled into a hollow pocket at the base of the head of a different sperm. These can get extremely long and even involve multiple different kinds of sperm. The Kamikaze sperm hypothesis posits that some sperm aren't meant for fertilization, and instead to sacrifice themselves in order to incapacitate the sperm of other males. And while this has been widely discredited in humans, it may hold true in some snails, which have 2 or 3 sperm types. There are the fertile eusperm, which operate as normal, and the infertile perisperm, which have other functions for sperm competition. In gastropods, these can be large carrier sperm, which eusperm can attach to for transport, likely meant to improve motility, similar to a sperm train. And there are the lancet-type sperm, which are thought to be used as chemical weapons. They contain several digestive enzymes, which may be released in the reproductive tract to kill off the sperm of other males. Sperm heteromorphism describes the simultaneous production of more than one distinct type of sperm. And this is another one of those cases where everything is a little unclear. Butterflies and stalk-eyed flies have long eusperm, which contain a nucleus, and short perisperm without a nucleus that are seemingly useless. In ground beetles, perisperm are large and even contain genetic information, yet still seem to be unusable for fertilization or anything else. Sculpin fish have large disc-shaped sperm, which again do nothing. Considering the consistent shapes and makeups of these supposedly useless perisperm, it's possible that they have functions that we haven't detected yet, or once had a function that is no longer necessary. That, or they're produced alongside eusperm as cheap filler, or simply by accident. Not everything in evolution needs to have a purpose, after all, but still, this is an area that needs a lot more research before we swim to any conclusions. Hey, you know what would be a real winning sperm thing to do? Subscribing and leaving a comment. I have a feeling this video won't do as well as my last few, just given the weird topic. So if you're enjoying this, a like and a comment would go a long way. Thanks. Okay, I want to end this video by talking about the effects sperm competition has had on human evolution. But first, there are some really cool examples of sperm competition that I couldn't elegantly fit earlier in the video that I want to quickly highlight because they're insane. These sperm, complete with 2 barbs sticking out of it, are found in flatworms. Flatworms are hermaphroditic, meaning they have both male and female reproductive parts. Some species go through the process of penis fencing, striking and parrying each other with the tip of their genitals until one lands a hit and injects their sperm. Sometimes flatworms will suck sperm out of their own reproductive tract if they don't like their mate, a showing of cryptic female choice. However, their spiky sperm has adapted to prevent this. The barbs work to lodge themselves in, sort of like a fishhook or an arrowhead, ensuring that they can only be pushed deeper and not pulled out. In roundworms or nematodes, this is a bit different. Their sperm don't even swim. competition. They crawl with a pseudopod exactly as an amoeba would. In the genus Caenorhabditis, the sperm can be very dangerous to females, sometimes busting out of the reproductive tract, invading other parts of the body. This is thought to be the result of very high sperm competition amongst the males, which the females have needed to adapt to in order to handle. When crossbreeding a Caenorhabditis male to a female of a different nematode species, the sperm completely ravages her insides, marching around and killing her or vastly ruining her ability to reproduce. Just goes to show how varying degrees of sperm competition, even within closely related species, can cause sperm to evolve and operate at completely different intensities. And lastly, when you add the sperm of a leafcutter ant into another one's seminal fluid, the invader sperm will quickly die. It's a result of intense sperm competition, using chemical degradants to obliterate rival armies of sperm. However, leafcutter queens need to mate with several males, all in one day before burrowing into the ground and producing children for 20 to 30 years. That means that they need to store usable sperm within themselves for that long. If the contents of the various male fluids were still harmful to each other, this wouldn't be possible. And so, inside the queen, she secretes an antidote, destroying the proteins in the semen that target rival sperm, effectively canceling out the sperm competition that the males worked so hard to evolve. Okay, we've covered more about sperm competition than sheets have been covered in Sperm. It's finally time to ask, how has sperm competition impacted human evolution? More specifically, how intense is sperm competition in humans compared to other animals? Well, the first place we should look is down, towards the male situation. Our testes size is larger than most other primates, and this is correlated with larger volumes of sperm per ejaculation, something that is obviously helpful for sperm competition. In line with this, we also have the largest penis of all the primates. There's evidence that injecting semen deeper into the cervix increases the chance of siring offspring, so our relatively big shafts and balls are both likely the result of sperm competition. That being said, we don't have a a literal boner that some animals have, which makes depositing and scooping out sperm as efficient as possible, and tends to be present in animals with high levels of sperm competition. So while we show greater amounts of sperm competition than other primates, it seems relatively moderate compared to animals as a whole. Supporting this is our own sperm heteromorphism, not in sophisticated perisperm and eusperm, but in working sperm and deformed sperm. It's common to find human sperm with 2 heads, 2 tails, or just be generally misshapen, at about 10% of the time. This is a lot higher of a rate than in animals with high sperm competition, which likely need to be more exacting in the level of their sperm quality to be competitively viable. In naked mole rats, only the queen and 1 to 3 males gets to reproduce, meaning there's barely any sperm competition. In support of our pattern here, 40% of naked mole rat sperm is so deformed that it's completely unusable. As a tribal species, we have a lot of natural behaviors that prevent sperm competition. A tendency towards monogamy, or pair bonding, is the main one, because it turns sexual rivalries into something to be settled rather than something to constantly fight over. It's also good for our extensive parenting behaviors. And these evolutionary incentives end up being built into our customs and taboos. Taking another mate is now called cheating. It isn't some primitive way to improve reproductive success as a male, but instead a serious social and moral flaw. It shows you as a bad partner, a bad parent, a bad member of the tribe. Still, that doesn't mean sperm competition is irrelevant to us. Most people aren't strictly monogamous, and we're still affected by feelings of jealousy or aggression towards someone flirting with your partner, etc. And yeah, our mating system might not be comparable to animals that form mating swarms where everyone has sex with everyone, but it still involves a level of competition that shapes the way we are today. Sperm competition is obviously much more complex than a simple race. It's a large-scale battle on multiple fronts, never ending yet always evolving. And that makes your achievement in winning it all the more impressive. Thanks for watching.